Hello. Good morning, Chef Young and Fuzzy. Patty was playing with something that she shouldn't have been playing with, so yeah. We'll get an early hello from Patty today so that she won't come interrupt our stream. Yeah. Good morning, Uchu. Good morning, Giovanni. Good morning, CS202 student. Good morning, Pig. Good morning, Turbo. So I think 11:30 today we're going to have a hiccup. Or not 11:30, 11:50 about. I think the stream will. I don't know, my computer like clears its cache or something right at that time. I think we can expect at least one pause, but other than that, the stream should go well. Good morning, Synthos. Good morning, Hamma. Yes, hello. Good morning, YCS. Let's place bets, all right? If I had channel points, I would do a gamba, but I don't have channel points, so. Will it happen at 11:50? Will it happen at 11:51? 11:52? 11:53? Will it happen at all? Who knows? Good morning, Turtle. Uchu, that's the lingo. I don't know how many of you guys are actually like Twitch viewers. I watch a significant amount of Twitch, and that's the lingo. You can gamble your channel points. The streamer will like place a bet, and with your fake currency, it's not real. You can like gamble on things, and they call it a gamba. So that's all I'm saying. If I had channel points, I'd do that, but I have to maintain some amount of professionalism. This is a UNLV class, so I don't want you guys like viewing advertisements during my stream. I have to like make you guys sub to me or something. So no, we're not going to have channel points, though I wish that I could. So today, right now, it's 10:26. It's 11:30, so we're going to get started. Let's go ahead and just take a brief moment to look at our syllabus, just to see where we're at. And also, for those of you who saw my Discord message this morning, I'm willing to take 10 to 15 minutes today. I might even throw some code in front of you to help you with the assignment. I know some of you have gotten started on that. Yeah, so looks like we've got some questions there. So I'll start off with that after we look here at the syllabus. So I just want to kind of update you on where we're at in the semester. All right. So we are at operator overloading our templates right now. Okay. And the next week is recursion and then exception handling. And so we do have a midterm coming up. Not next week, but I think the week after. All right, so I just want you to be aware of that. I would say the week of November 8th, we're going to be doing a midterm. I'll be sure to update you on that when I get some more details. But just be aware that that is coming up. All right, now my guess is I'm not sure if we're going to have time to really cover this. For the most part, I may just give you some notes on that. Exception handling, really, Don't tell the other instructors that I said this, but personally, I don't think it's very important for a CS202 class. Of course, depending on your profession, there are some environments where you'll need to use exception handling. In this case, I don't really think we do, so I'll give you a brief introduction to it, but I don't think we'll spend a whole day on it. So midterm 2 will cover everything here. Now, midterm 2 is not cumulative, meaning we're only going to ask you questions about these things, all right? These 4 topics, all right? So it's not cumulative. So we'll talk about recursion, templates, operator overloading, virtual functions, and abstract classes. There will also probably be some multi-dimensional memory stuff on there, right? Creating a matrix in multiple dimensions. But for the most part, we're going to be skipping this stuff. I mean, obviously, in order to correctly understand virtual functions and abstract classes, you also need to know about inheritance. So, you know, don't sleep on these things. Just because I'm not going to be asking you what, say, a public modifier does, you still should understand these subjects pretty well, because you'll need them to answer these questions. So I hope that makes sense. With that being said, are there any questions I can talk about that? I see we've got some assignment questions in, so I'm going to go ahead and move on to that. But if you have any questions, please let me know. Okay, so here we are. So we'll start with Chef. For the assignment, we're kind of asking how are we supposed to allocate this pointer in the matrix class, right? Now, Chef is right. I kind of specified there on assignment 6. If you look at that PDF, we're going width first, all right? You can kind of go find it somewhere in here. The matrix is always accessed as xy, where x is the width and y is the height. So the first thing you should allocate is the width. So I hope that answers your question, Chef. Uchu says, how to globally declare through an H file. Well, think about it like you're in main. All right, so obviously I'm not going to want you to put that in main, all right? But what you can do here is you can say, hey, here's my class matrix, right? And in here, you're going to put some stuff. You might even have something that says friend, void, you know, my function or my op, right? Which takes, I don't know, some parameters. Now, you're in the H file, so let's just put the header in here, all right? So void, you know, my operator. There's the header. So there's your header. Here's your friend declaration. And then go to the matrix.cpp file and just say void myop, and there you have it. Your code here. This is the definition. Is that fine? Does it make sense? Obviously, we haven't done something like that before, right? But I mean, as far as we know, it kind of works the way you would expect it. That, you know, kind of in main, you would just put the headers up here, and then you'd put the definitions anywhere else, really. I mean, we'll usually put them down here, but that definition could go anywhere. In fact, if you really didn't want to put the definition in here, though I would recommend you do it, you could just do it here if you wanted to. It really doesn't matter as long as this definition exists somewhere in the CPP or H file. You're also going to need to make sure that it's declared as a friend. So it appears I answered that question. I'll take that as a yes. Pig says, why are we doing float pointer pointer? So a double pointer instead of just the regular, you know, square brackets. Well, to answer that question, this matrix can be of any size, meaning you need a dynamic array. All right, you can't. So here's what I ask you is up here. You're gonna have your float matrix. Now, what if instead of doing that, you did this? Now, at this point in time, you have to specify what the size of this is, all right? And the only way you can do that, at least legally, in my opinion, is you need some constant integers, right? Something like w equals, say, 3, and const int h equals 3, something like that. And then at that point, you can specify it. But guess what? This matrix is now of a constant size. So then somewhere here in main, I can go find it, actually. Let's see here. Probably right here. So case 11, notice this is a 10 by 10 matrix. This is a 3 by 3 matrix. And then look what I say here. M1 equals M2. Meaning I'm assigning a 3 by 3 into the 10 by 10. At this point, you have to resize the array. Now, if you're doing this, you're stuck. All right? You are stuck. Why is it mad? You're stuck. Does it make sense? You have to resize this. And the only way that we resize arrays in C++ is by using pointers. So kind of last class, I was doing it like this initially. And then I really kind of wanted to help you out a little more. Right? We did a mini matrix class from last class. And I started out with this. But then I said, you know what? I want to help my students out here. I'm going to switch this to a double pointer so that I can kind of give you some more code, right? For, say, that assignment operator overload. Pig says pointers gives you more freedom when you're coding. More specifically, it allows you to resize an array. You know, you can store an array of size 3 into that pointer, and then you go, oops, now I need an array of size 10. So what do? You return the address that contains or that holds the array of size 3 to the operating system. And you say, hey, operating system, now I need an array of size 10. So yeah, it does give you more freedom. I would say it's a requirement. If you're doing anything with resizing, anything dynamic, you need that pointer. And this assignment is specifically working with that. This is very dynamic. All right, we're going to go from, say, a 10 by 10 to a 3 by 3. So you got to return that 10 by 10 to the operating system. You need to request a 3 by 3 from the operating system, and then you need to make a deep copy of that matrix here on the right-hand side. Sithos says, how does the, that's the extraction operator go to read in data? All right, well, so I'm okay doing this one. So what does that one return? Can anyone tell me? We're doing the, let's pretend here we're doing the operator this, all right? What is it? It returns an I stream, and it returns it by reference. Specifically, it returns it by reference. Okay, so that's correct. Now, obviously, this operator has to be global, right? At least that's what I said in the notes. You cannot make this one part of the class, and the reason for that is usually, not usually, always, the stream is on the left-hand side of this operator. Okay? So Syntho says, this one takes info from CN or from files. Yes, that is correct. Now, you'll see in the main CPP file, it's only called ever with CIN. Though, if I wanted to, I didn't do it for this. If I wanted to, though, I could potentially have an if stream in file matrix.txt, and I could in file to say M1. I definitely could do that. Notice that what the I stream is what's provided as a parameter. So either it's the in file or it's the CIN. Specifically for this assignment, it is the CIN. But here's what you have to pay attention to, is that we're going to be providing an I stream. Name it in, don't name it CIN, right? Give it some other name. I like in. And then you need to pass the parameter. Synthos, I would recommend watching the assignment video that I posted. Those input files are so you can like kind of provide the input during the runtime. Notice here, let's see. There's a really annoying one I made you do. Let me go find it. Right here. So this is a 4x4, so that's 16 inputs. That's a 4x4. That's also 16 inputs. And then I see into both of them. So how many total numbers are you going to have to enter on the input? Well, that's 32. Right? That's 32. But you can actually just take that file I gave you and provide it as input. And it's going to make it so you don't have to enter those numbers one by one. The reason you have those input files is to kind of save your life a little bit. So I'll show you what I mean, I guess. I don't think it could hurt. This is case 5, all right? So if I run this as is, and I select case 5, now it's going to wait for me to put in 32 numbers. Are we having fun yet? When will it end? There. 32 numbers entered. Isn't that fun? Right. So obviously I don't want you to do that. I don't want you to do that. All right. So look at the test I provided for that. Where is it? Number 5 is the plus operator. So where is it? Addition operator. Addition operator dot txt. So instead of doing what I just did, say ./a.out, this little left caret, right, less than sign, and then put addition op.txt, and it will literally provide that input for you. It happens like right here-ish. You can't see it because it's being consumed from the file, but that's how you kind of redirect input onto that. Does that make sense, Synthos? That's what those files are for. Not to like open, just to provide on the terminal. Yeah, it's a lot more fun than putting in 32 numbers. Absolutely. There's one of them that I make you put in 100 numbers somewhere. I think here. Yeah, that's 100 numbers right there. You want to insert that? No, you don't. You want to use the file. Okay. So back to this one, right? This takes, this returns an iStream by reference. It should take this by reference. And then let me ask you this. This is going to take a matrix. Is this one by value or by reference? What do you think? This is definitely by reference. You're going to want it to be by reference. The reason you do that is because you're going to be reading into this. So you're going to want to modify the original. See here, main. This is the original matrix, right? And so I'm basically calling this like a function. I'm saying operator that, pass in cin, pass in M5. Right? That's an equivalent statement there. This might, I think this will compile, by the way. If you never want to use operators again, you can just call them like this. Isn't that awesome? Now, this is a parameter, right? An argument. You're going to want to modify this one. You're going to want to input 100 numbers to this M5. And by the time you get here, you want to make sure those 100 numbers are actually in that object. Right? So yes, you are modifying this parameter. And because you're modifying it, you're going to want to pass it by reference. So there's your skeleton. First thing you should probably do is say, hey, let's return in, because I don't want to forget that part. Right? When you return in, that's going to allow you to do stuff like this. I don't know, X, something like that. It allows you to kind of append some more stuff on there. All right. And then the next thing you need to do is say, hey, let's make this a friend, right? You are now my friend. Whoops. There you go. And then in here, you're probably going to have a... I'll leave this one up to you. I think I kind of already did it in class. You're going to have some for loops in there, right? The for loops, you're just going to say, hey, in, you know, to my matrix at, I don't know, I, j. Something like that. Make sense? So, the person who originally asked that, Synthos, are we clear on this? Does it make sense roughly how this is going to work? And of course, you can just put the definition here. You can also just leave it as like a header, of course, if you want. And then you can go in the CPP file and put it there. Cool. All right. Are we good? That's about 15 minutes or so. If there's a last minute question you'd like to ask, let me know. But we're going to move on to templates for the day. Now, I didn't get that open. Also, I'm trying to jinx it, guys. 11:50 is approaching fast. So, you know, you guys placed your bets. So keep an eye out. What time was it? I'm betting 11:51 a.m. All right, so we're going to go here. We're going to go... friends, where are we? Okay, that looks good. All right, so templates are kind of fun. We are going to have some notes today. I mean, we always have notes. We do have a question here. When I make my matrix pass by reference for the iStream, it says the matrix is inaccessible. Well, I would ask, I guess, a few questions about that. For one, did you make it a friend function? That's something you should consider. In addition to that, these have to match. For every single one that you have, yeah, Synthos is right. He gave me that idea. You got to put it here, you got to put it here, and then you got to come down here and you got to put it there. Did it happen? I don't know. All right, guys. So, I'll go ahead and close all those. And we're going to move on to our notes. Now, templates are really fun. They're kind of the last bit of polymorphism that we're going to talk about in this class. Don't crash my class. All right, so templates are very, very nice. Okay, templates are very nice. We're going to love them. This is this is some type of polymorphism. All right, you can kind of go back in the notes. There's my 11:50. 11:50. We did it, guys. 11:50 on the dot. Man, that's amazing. Okay. So, we're talking about templates here. Remember polymorphism? All right. Name them off for me. What are our 4 types of polymorphism? I'll give you this one, templates. Name some other ones for me. Name some other ones for me. What's our polymorphism? Obviously, we've got a delay now, but you guys know this, right? Remember what polymorphism means, right? Having many forms. All right? Having many forms. So what things have many forms? All right, yes, operator overloading. That's a good one. This operator is taking many forms, right? Virtuals, yes. Virtuals. This object has many forms. I think we've actually got 5, don't we? Well, I'll kind of group this one in, virtuals and function overriding, right? I'll kind of... I don't like that. I can spell, I swear. All right, I'll group that one in there because that's kind of where the function override comes in, right? And then, of course, function overloading. Okay? You did it. Nice job, guys. So that's our polymorphism. Now we're on to templates, all right? So a template is some type of polymorphism, all right? Some type of polymorphism. Now, how does this thing work? Well, it is a function or class that is specified to handle multiple data types. Is a function or class that is specified to handle multiple data types. Now, I just kind of want to see if you remember, what template have we used before? There's a template we've used before. What template have we used for? There's something that we've used that is a template. You guys know this. I did bring it up. While I'm waiting for that, you guys know what it is. I'm just going to kind of bring this back up again. I believe I talked about this previously this semester. What does it mean to be general? Well, it's kind of the simplest representation of something. Now, maybe not the simplest, but a simple representation of something. So I would say something like, say, virtuals are, they're very general in that they handle many cases. I'm going to say no to both of those. So I'll answer the question in just a moment. If anyone still has an idea, let me know. We used it in assignment 5 with the fishes. Assignment 5 with the fish. There was a template in there. I had to teach you about what that thing was. All right, back to this. Things that are general handle many cases. Things that are specific handle only a single case. Or a little amount of case, right? Not very many cases. A little amount. A vector, yes, yes. It's a vector, right? We have used a template before. It is the vector class. We've used vectors. It's a vector, right? And how do we know that that is a template? Well, when you declare something, you say vector type, right? You put the type in here to say, hey, vector, you're going to be equipped to handle this type today, right? This is a generic type in that this vector is going to hold ints. It's going to hold strings. It's going to hold floats. It's going to hold fish pointers, right? So that's what a template is. It's any class or function that's equipped to handle a generic type. All right. So I was kind of talking about, just the generality of things. Templates make things very general. And that's something that is a template will handle many cases, right? In terms of a vector, we're not going to have an if statement. If we're using ints or floats, we can just give it to the vector and it's going to handle it, all right? So now we've talked about that. I guess we need to kind of talk about how templates work and what we can do with that. So the first thing we'll do is just define what a template does. I already kind of talked about that, right? What is a template? Well, you can provide the function or class with whatever data type you want. And the code you type will handle that case for you. So these are pretty cool. So I'll kind of give you the idea of this. Traditionally, let's go ahead and start some code here. Traditionally, if let's say you were going to be coding something that, all right, I'm a little lost here. You were going to be coding something that sorts lists of different types. All right, so that's going to be our first example for today. And I ask you, I'll kind of put it in front of your face here. Let's say we've got a few arrays here. 10 is too much, all right? Let's start small, and let's make sure that these are out of order. All right, that's definitely out of order one way or the other. And then we can add a few more. Perhaps a string, and perhaps a float. Float's too easy. Maybe a character. So this string is going to have, I don't know, let's include all of the cats that I've ever had in my life. Miss Patty. We've got Miss Loaf. Now these are my parents' cats. We've got Miss Diva. We've got Miss PETA, which stands for pain in the ass. And we've got Willa. Okay. And then we're going to do some characters. So, I don't know, we'll do C, A, and Z. So, I'm going to ask you to write a sort function for these. She wasn't that big of a PETA. She was a wonderful cat. She was a wonderful cat. So I'm going to sort these. Now, when I got to get the English out today, guys. Previously, with what we've learned, how would we accomplish defining a sort function or multiple sort functions to equip this? In that, if I call sort on the I array, I would want it to be sorted. All right. Similarly, I would want to sort the string array and the C array. Now notice I'm providing different parameters here, right? But I'm using the same name. So what is that called? Yeah, Chef is way ahead of me. Function overloads, right? So we are doing something here. Say, you know, this is going to be an int array. That's what that comes in as. But then you need another one, and then you need another one. All right, one for strings. And you need one for characters. And yes, we will use bubble sort. Turbo, we will use bubble sort. So there we have it. Now, let me ask you, is this solution specific or is it general? Is this a general solution or are these specific solutions? What do you think? They are specific solutions. That is correct, right? These are specific. Why? Well, this only handles a single case. One case. It's a specific solution, right? So now we're going to move into a general solution. This is what a template does. In which we're going to say, you know what? I don't need these. We're only going to write one sort function, and it's going to be able to handle all of the data types. Are we excited? I know I am. I know I am. So I'm just going to go ahead and declare these sizes because these are not classes. There's no get size method. All right, so I'm going to kind of need to have them as separate variables so I know what I'm talking about. All right. So that should work fine. So we're going to start off with this. This will be our example, and I'll make this a template. But first, let's kind of take a step back to our notes. Nice job today, guys. We are on top of it today. It is Tuesday, right? It's not Monday, so we're maybe a little more awake than we generally are. At least I know I am. So let's talk about coding templates, all right? As I said, there's not too many notes for this one, all right? We're only going to spend a little bit more time coding, and that will be that. So, there's two things we have to consider. There's two cases, right? We have coding templates for, say, some functions, and we also may be coding things for some classes, all right? So there's kind of two cases that we need to consider. So we're going to start with the functions, because that's what we're starting with, is sorting, all right? So there's two options. We're going to refer to something as the template type. So let me define that real quick. The template type. This is a type representing a generic type. Meaning this template type, will become some other type. Hopefully that makes sense when I say that, right? It's going to become a string. It will become an int. It will become a fish pointer. All right, so a dish pointer. So when I refer to the template type, I'm saying that this is just some type that's representing a general type, and that it will become some other type. All right, it will become a string, an int, or a fish pointer, or a dish pointer. So for functions, the template type can be included in the parameters. All right, that's kind of case one. Or the template type can appear somewhere in the body. That's case two. So Uchu asks, do we return the generic type or the other type? It's up to you. It should make a little bit more sense when I start coding here. This is a sort function, so likely it's still going to return void. But we're going to equip this function to still be a template. But I guess to answer your question, in many cases we can return a generic type. We will have an example of that where we'll kind of code something like our own vector class. And I'll show you how that looks. So for example, you know, when you have, say, your vector, your own vector, and you say int v, and then you say v dot push back, I don't know, 10. And then when you say cout v at 0, you would expect this to return an integer, right? You would expect that to return an integer. And that's because this vector is taking a type of an int. Okay? So, yes, you can return the generic type. But in other cases, this is a void function, right? This doesn't return anything. So it's up to you. You can return whatever you want. So we'll start out with case one. All right. If the template type is in the params, you can just call the function with the name. No. I don't want to become famous. You guys might lose me here, just so you know. I should pull it up on my phone, but I will handle it myself. See ya. Okay. So back to this. If the template type is in the parameters, you can just call the function with the name. Now, why is that? Well, the compiler can tell which template you're going to be taking the form of, right? The compiler can tell which form the function will take based off of the parameter provided, based off the type of the parameters provided. So what do I mean by that in case one? Well, let's go ahead and get to coding. Now, I'll include the syntax in the notes, but let's start up out here, all right? Now, if I want to make this a template, the first thing we have to do is say template. And then in here, we're going to include all of the types that we want to. Now, we're going to only start off with one, all right? We're only going to start off with one. And whatever you want to, you're going to have to, like whatever type you're going to want to use, you're going to have to specify it as either a type name or a class. Now, we'll talk about that in a little bit. But then you want to give it, say, some name. My favorite name is always type. All right, sometimes I do T1, T2, stuff like that. It really doesn't matter what this is. It's like a variable name. All right, you could name it Patty if you wanted to. It's just some type. So now, everything that's underneath this, at least in the function, you can use this type name anywhere you want as if it's the type of some variable or object. So we're going to use type. And if I'm going to be sorting, I'm going to need the size of the array. But I'm also going to need the array. Where would I put type here? What parameter in this function is going to be taking the generic type? What parameter? I probably said that completely incorrectly. What parameter is taking the generic type? The first one, right? The array. So very simply, I can say, hey, type. Are we following this? So I've specified this to be the generic type. All right, pig, you're right. And so now we have access to this as if it's its own type. And I'm going to say, hey, I'm going to sort an array. This array can be of any type, so therefore it is a generic type. So now we're ready to go. Let's do bubble sort. For int I equals 0, I is less than the size minus 1, I plus plus. Next one, for int j equals 0, j is less than the size minus I minus 1, j plus plus. If a at j is less than a at j plus 1, we'll swap them. Well, to do a swap, we need a temp variable. What type is the temp variable? What's the type of the temp variable? And then I'll say something like a j plus 1 equals aj. And I'll say aj equals temp. It's a type. Are we following this? Type temp equals aj plus 1. So I see we got an int in there, Turbo. I'm sorry that that's happening. I'll leave it up to you to rewatch on YouTube. Sorry for anyone who's on campus. But for those of you who are not being currently evacuated, does this make sense? This is the generic type. All right, so this is going to become a string. This is going to become a character. It might be an integer. No, you're not a fool. I just want to make sure that we understand. We understand what's going on here. What type are we swapping? Well, we're going to be swapping elements in this array. So what is the type of that array? It's a generic type. So very easily, we're just going to declare a variable of a generic type. And there you have it. So guess what? Now when I'm down here, I can say S size and C size. And it will work. Synthos asks, so the type can take any form of any data type. Yes, it can. Yes, it can. All right. Notice here that and this is what I was talking about in the notes, the template type is included in the parameters. Do you see that? It's included in the parameters. And because it's included, when you're down here, the compiler can tell which kind of generic type you're going to be taking. It's possible to make a pointer type. So, Hamma, here's what I would say. This can be anything. It can literally be anything. So when you ask, is it possible to make a pointer type? The only way I can think to answer that is this could be a pointer. This is going to be goofy, all right? But, bear with me. I'm not going to make it 10. I could do that if I wanted to. I could do that. And then I could say sort the P array. And it would be okay. If I wanted to do that, yeah. This is like, by the way, this is like a two-dimensional array. This is like your class or your matrix class. These are just addresses. This is just an address. What do pointers hold? They're addresses. What is this? This is an array of pointers. This is an array of pointers. What is the type? It's an int pointer. It's an array of int pointers. Now I'm converting them. I'm making sure the compiler knows that I want this to be an int pointer. But all I'm saying, these are just addresses, right? And I can sort it if I want to. And up here, this will take the type of int. And then this will take the type of int. Does that answer your question, Hamma? Was I on board with that? You can provide it whatever type you want. I can even say so you're asking, so it cannot be a pointer to a type. So no, you can't do this. If this is what you're asking, no, you can't. But this is equipped to handle any pointers. It's equipped to handle any type at all. So this is an int pointer. If you were to call sort on this, this would become type int pointer, and then you're working with pointers. So I think what you're thinking is a little specific. This is as general as it can get. This is the most general. So the answer to your question is, yeah, it can be a pointer. You don't have to specify it. It's already equipped to do that. And the reason is this is its own type, right? A pointer is its own type. What is the type of this? It's an int pointer. Okay? If you think back to assignment 5, you had the fish list. And the fish list held fish pointers. So, yeah, it's equipped for all of that. It's equipped for all of that. Now back to this here. I'm not going to really spend too much time doing this, but I could say have a float mat, right? And maybe some sizes. Something like that. So we have a basic matrix class there. I could do this if I wanted to. Should work. Now what do I have? I have an array of matrices. Can I sort it? You are dang right I can sort it. What does this do up here? This takes the type of the matrix. Now I'm going to ask you one question. This is very important, and I always like to ask this on the test. So I want you to use your critical thinking skills. We're going to have no issues with these ones, but this code will not compile as it is with this matrix array, in that I'm sorting it. The code will not compile. Now, just based off of this code, replace everything in here that's a type with a matrix, and can you tell me why it won't compile? While we're doing that, I'm going to come up with another template function. Now, what I'm asking you is tricky. I just kind of want to see if we're on board with some things here. Now, this next function, Chef, you are on top of it. Yes, you are. I'm very proud. I'm very proud. Look at this, guys. Look at this. This is a user-defined operator, right? Our type. This is a user-defined type. This is a class. We have two issues in here. One is the assignment operator, right? Now, the code will still compile, but you're going to get a shallow copy here. Now, up here too. Do you see this? What is this comparing? This is essentially saying, is this matrix less than this matrix? So, pig, suggest here that we have this array of matrices and we're going to sort them. So when we call sort, we refer to this code up here. Now we're using this template function. So what you have to do is come in here and say, all right, this is going to become a matrix and this is going to become a matrix. And now you take a step back one section and talk about operator overloading. Does this line of code work? That completely depends on if the less than operator is overloaded. Is this going to work the way we expect it to? That depends on if the assignment operator is overloaded. So Uchu, it does know which matrix is which. I don't know if this will make... these are just default matrices, but they're all different. They're all different. It's just like M1, M2, M3. I want you to imagine that they have values. I don't want to code this in front of you right now because we kind of did that last time. I just want you to imagine that they have values. So they're different ones. They are different. They're different. All right, so pretend they have values. And now we have an array of them. And up here, when I say A at J and A at J plus 1, we have two matrices that are different. These are guaranteed to be different matrices. And now you just have to consider what operator we're working with here. This is saying matrix less than matrix. This is saying matrix equals matrix. Are those operators overloaded? So Chef asks, how do you overload those? It's just like any other operator. In the assignment, you don't have to do a less than or a greater than, because for matrices, that doesn't make very much sense to me. Though, unless they have the exact same size, then how do you know if it's less than or equal to? It's up to you, right? You're the programmer. You're allowed to come up with that. So for this, it looks like this is going to be called, it looks like this has to be a Boolean. So we're just going to say, like we would, operator less than matrix right-hand side. And you have some code in here. And then, I don't know, you return false. Maybe not false, right? You'll return something else. But, I mean, this isn't anything new, right? You guys know how to do an operator overload. Now, you can check the C++ operators. You can also check the notes. You'll know that this one can be global or it can be a class member. So Pig asks, we have to overload the equals operator because it won't copy the correct values. For that, you're going to want to refresh the video and the notes that we talked about on the day of the rule of 3. All right? If you don't overload this, you're going to have a shallow copy. You're going to have something that's like mat is equal to copy.mat. And that's a shallow copy. So yeah, it will have the correct values, but now you have two objects pointing to the same location in memory, which is not good. You have to overload it to make a deep copy here. So I would go recheck those if you can. But the main point here is that this is a generic type, and so you best be sure when you are doing something, say with this function, you have to be aware of this. Is that this is a template type, meaning anything is going to come through here. Ints, strings, floats, matrices. And if some matrices come through here, you're going to be using the less than operator. Is your code breaking? Maybe. Well, that's because you didn't overload that operator for that type. Pig says, when deciding if an operator should be global or a class member, do you recommend you just go off your own preference? True. I would say that. In my opinion, if the object is on the left-hand side, I would make it a class member. If you're considering something like this, if you're going to do something like M3 int x equals 2, if you're going to do M3 plus x, do you think this overload, based off of just what I said, do you think this would be a class member or a global operator, based off of what I just said? And then I'll ask you the same question here. Is this one a class member or a global operator? Here we've got matrix plus int. Here we've got int plus matrix. So is this one going to be a class member or global? Or is this one going to be a class member or global? This one, I would make it a class member. Yes, I would make this one a class member. Though it's not required. It's not required here. Now what about the next one? Let's see. Pig says there's no in class, so global. This one has to be global. This one absolutely has to be global. And why is that? Try to put it in terms of the object. All right, try to put it in terms of the object. So what does this look like? It looks like operator plus, the x is passed, and the M3 is passed. What is on the right-hand side here? What is on the right-hand side here? Well, it's M3. And so if it's on the right-hand side, there's no way that M3 could be able to call that. It's on the right-hand side. So the only thing that would be able to call this is x.operator plus M3. But x is an integer type. It's a primitive type. And so it doesn't have this thing. You can't overload that. So what do? You do it this way. You do the global operator version. This is the global version. Does it make sense? I guess we take a little step back there, but I think that's fine to talk about. Does this make sense to people? This one could be, I would make this one a class member just because the object's on the left-hand side, but by no means is that required. Just to be consistent, I would say, yeah, I'm calling it from the object, right? The object could call it like this. Now down here, you don't have that option. This one has to be global. Why? Because that int is the left-hand side. So there's no way that the object's going to be able to call it like this. Please tell me if that makes sense. I want to make sure we understand that. Some people may be lost right now in that Rainbow Land from Rick and Morty. I don't remember what it's called. So Klaus asks, would it just be easier to make it global because we wouldn't know which side it would be on? Well, from last class in the notes, we talk about the order of the operators matter. So Klaus, in this case, we have an int plus a matrix, and we have a matrix plus an int. All right? So you need both. You absolutely need both. You can't, you don't have a choice, unfortunately. You're going to need a matrix operator plus matrix int, and then you need another one. The order of operands are important. They matter. Now, Klaus, check this out. If you're interested, let's suggest that they do the same thing. Well, let's say in here you've got, I don't know, 4 the width, right? You've got 4 the height, and then you say add int to all elements, and then return new matrix. So let's say you typed out all the code for that. You've done all the work here. Are you going to do that again here? Sure, you could copy paste that code, but is there an easier way? Does anyone have any ideas what I could do in this one? Suggesting that I want them to perform the same, but in this one I typed all of the code, and now this one I don't want to type all that code. Is there an easy way that I could make them, is there an easy way I could make this code work without retyping all of this code? I hope that question makes sense. I was kind of hinting at this in the assignment too. Say I've got 40 lines of code in here. This one is going to do the same thing. Yeah, Chef is right. Call the already overloaded operator. So what can I do? I can say, return, well, x plus m is not the right, so I'll say m plus x. Notice that this is the matrix here, so it calls this operator, and this is the x here, so it calls that operator. And then I could even one-line that if I wanted to. Bam. I can even kind of condense them. Now they're doing the same thing. So Chef, nice job. Klaus, does that make sense? I mean, yeah, you said you understand that the order of the operands matter, but you can, if you're going to do something like that, you can really make the second operator super easy, right? You can make the second operator very easy. Similarly with the equal operator and the not equal operator, they do opposite things, right? So, hint, 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 what's the thing to make something opposite? Not sign, right? So, take that as you will. So I hope we're okay with this, right? Just to refresh, I would make this a class member, but you don't have to, right? Up here I did it so that it's not. In this case, this one's global. So it's totally not required, that one. Notice it's not red anymore. It is mad at me because I didn't do the other operator, but that one's fine. And then this one has to be global. It's a requirement. So I hope that helps. I hope that helps out, folks. I'm going to get rid of this stuff. Now, coming back to this idea, I hope we understand what this part is talking about, and I'm going to ask you this question. All right? I'm going to do another template. Someone give me any type name you want. Someone give me a type name. Floopy. How about that? Yeah, you're right, Chef, right? Funny name. Whatever. It can be named whatever we want. Now, I want you to understand that this template up here is in its own scope. And this template is also in its own scope. So I could name this as type. Deborah, that's a good one. So before I name it Deborah, do you understand that this type, which is referring to the print array function, is a different type than this one? It's just like variables, right? You guys have seen this before. Please make sure that we're on the same page here. We should understand that this int x and this int x are different, right? Down here, we're going to see, if you see this code, we're going to see 3 here, right? Because this x is different than this x. They're in different scopes. They're in different scopes, right? You guys should understand that. If you don't, you're going to need to think about it. Similarly, this and this are in their own scope, meaning this type is completely unassociated with this type. Synthos asks a question, when does C++ know when the scope ends? Can anyone tell? Can anyone tell Synthos that? Describe it in terms of functions, and describe it in terms of the class. When does the scope end, guys? How do you know that? When does the scope end? The closing bracket. Right? So, Pig, you're right. Chef's answer is my favorite. I don't mean to play favoritism, but that's correct. When does the scope end? It's when you see that closing bracket, right? Which is the end of the function. All right? So when does main scope end? Well, this is the end of main, right? If we come back to this example, when is the end of this scope? Well, this is the end of the if. So if I say cout, I don't know, let's make this say y. This is not known, right? Because the scope ended at the closing bracket. Does that answer your question, Sithos? Scope ends here at the closing bracket. So y doesn't exist. So when does the scope end? At the end of the closing bracket. Now, if you think about it, if you've got a matrix in here, M, 5, you've got the pointer, right? Float mat. That exists inside of M5. When does the mat go away? Well, when the destructor is called. When is the destructor called? At the end of the if statement. So it's almost always here. It's just the closing bracket, right? So, Hamma kind of said when a new template is declared. Well, think about it this way. That's not entirely correct. The end of this template ends right here at the closing bracket. This is end of function. So type, no longer referred to here. Okay? This is the end of the function, therefore the type is no longer referred to after this bracket, right? So this type immediately becomes, its scope ends. It's no longer around. So down here, if I declare a new one, I could name it type. And how big is its scope? Well, it goes from here to the closing bracket. Does that make sense? I hope it does. Next class, we'll talk about a template contained within a template. All right, now that's where things get a little dicey. But kind of Hamma, to answer your question there, when a new template is declared, that's not 100% correct. Because what if there's a template inside of a template? Okay, so you have two templates that are working together in some sense. We'll talk about that next class. So get excited. Doesn't always have to get complicated. Why are you mad? Don't be mad. Be glad. All right, so come back up here. Remember what the issue is here, right? This is going to work for all types, except those custom types that don't have operators overloaded for these objects, right? So let's come in here. We're going to print an array. So all I'm going to do is for int I equals 0. I is less than the size. I plus plus. And I don't know. We're going to see out the array at I. Now, similarly, do you foresee any issues here? Let's pretend Deborah is an integer. Probably no issues here, right? That makes sense. What if Deborah is a matrix? Do you foresee any issues? And what is the issue? What is the potential problem in this function? Depending on what form the generic type takes. What is the issue? Can anyone tell me? Remember, this is an array of generic types. So array at I comes out to be, I don't know, a pointer, an int, a string, a matrix. What's the issue here? Synthos, you're correct. Absolutely, you're correct. Right? What happens if this comes out to be something like cout matrix? Well, is this operator overloaded? Do we follow that? Up here, we've got some issues. Less than sign, right? Is that operator overloaded for all types? Assignment operator. Is that operator overloaded for our pointer types? Here, is this insertion operator overloaded for our template types? So I hope that makes sense. We're kind of coming up on the end of class here. I know you guys, your head is probably spinning. So we'll probably just kind of leave it at this. And then we'll get to the next part next time. But let's at least try to run this code and have a little fun with it. Now I'm going to comment out the parts that I know won't make very much sense, because I don't want to worry about it. But let's at least say print these arrays. The I array and the I size. And then we'll sort it. Similarly, we'll do that here. And then similarly, we'll do that here. And let's just make sure that our code works. And just remember, this is an integer, this is a string, this is a character. Let's go look in here. Strings, ints, and characters will work here, right? We know that. Strings, ints, and characters will work with this code. What about up here? Strings, ints, and characters will work with this code. They'll also work with this code. Now, of course, I got this big matrix thing up here. We don't need it. Not for today. So how are we feeling? Are we a little sad right now? Are we upset? So here's our first one. This is the original array, right? And we called a generic sort on it. Notice the print function is also working. Notice the print function is also working. So we sorted that array. Look, the exact same code worked here too. It's doing greatest to smallest, right? Greater to least. So we've got Willa, Pita, Patty, Loaf, Diva. And notice, look, it did the same thing for this. So I hope you at least understand what happened here. You're going to have some time to practice with it, right? Next class, we're going to spend some more time on it. You'll have some time to sleep on it. And we'll be making more sense next class. I've just kind of planted the seed, right? So we just wrote 2 template functions today, and they work. Synthos says, I'm wondering when we'll ever learn all of C++. Well, I'll tell you, even I still don't know all of C++. That's because they keep releasing new things. I know all of C++ 11, and I only knew that when I started teaching this course. What's more important as a takeaway from this course is that you need to understand the concept more than anything. There's a million programming languages, and all of them, Java especially, and C#, have these things. They have inheritance, they have objects, they have dynamic memory, they have virtuals, they have templates, they have operator overloads, they have everything, right? So we're learning them in C++. And, you know, even if you don't exactly remember how to do it, you need to know where to reference it. And you need to know at least what's going on. And that when you're given a job as a professional and you're working with Java and they start talking about templates, you can say, I know what that is. I know what that does. And I can reference something that can help me make some Java code to do something like that. Hannah, no, you don't need to use templates for assignment 6. All of that stuff was covered last week. Synthos, yeah, there's tons of languages. C++ is most similar to Java, C#, C. Those programming languages, which are some of the largest in the world. Perhaps JavaScript. Okay. So that's it for today. Thanks for coming. I hope you did learn something. Even though right now we're probably still a little bit up in the air. Next class we'll really finish out these notes. All right? We're going to finish out these notes. We're going to talk about a few other things, okay? So just sleep on it. And I don't think we died. I think we're still here. Well, regardless, it's the end of class now. So you're free to go. As I said, I hope you learned something. I hope you had a good time. I hope you like seeing my face. I like seeing you guys in the chat always. I hope you have a great day. I'll see you on Thursday. All right? Uchu, you're welcome. Yang, you're welcome. Pig, you are welcome. CS202 student, you are welcome. Brandon, you're welcome. Klaus, you're welcome. Sithos, you're welcome. Hema, you are welcome. Have a great day, guys. Turbo, you're welcome. Kane, you're welcome. Fuzzy, thank you. Chef, have a great day, man. Thanks for coming. Thanks, Hammer. So I have the webcam here. You gotta look at something.